How's it going, everyone? Today I'm going to be installing the Turner Motorsports toe arms on the BMW M2 competition, and the reason why I want these, and they're a very popular upgrade, is that the stock arm has a rubber bushing on one end, and that rubber bushing allows some deflection of the arm to happen. So that means your toe can change under certain conditions, you know, heavy braking, cornering, etc. And we really don't want that. Okay, so let's talk a little bit about different types of rear toe arms you can get. And so on the bottom I have the Turner, which I've actually had in the car at this point for a little while, and you know, it's definitely done its job, you know, gave me the extra toe adjustment I needed, but I've decided to replace it with the SPL. And if you ask why would you do that, you know, go through all the effort of dropping your subframe again just to do this, it's because I really hate using these jam nuts. You know, when you lock down these jam nuts, it typically changes the alignment a little bit. So what you actually have to do is you have to set, you know, turn the main, main rod so that you're at the toe setting that you don't want, such that when you tighten the jam nuts, it goes to the toe setting you do want. Now you could say, sure, close enough, but this is really triggering my OCD here. So I've decided to go with the SPL because the SPL uses these collars which clamp around the adjustment, and so you're not turning anything, you know, slightly adjusting it, meaning these are going to be faster for me to get on target and stay on target. Now I was really surprised at the difference in the tube thickness or outer diameter between this Turner one and the SPL. And in fact, Turner actually makes multiple toe arms. So you can see this one here, which is obviously a lot thicker than the SPL one, but Turner also has a branded version of this SPL one. They call it their performance toe link, versus this is just, I guess, their regular toe link. But this even also has options. You can get a nickel plated rod end, or you can get a stainless steel one, which costs a little bit more. Now, if you ask what's the difference, or you know, why does that matter? Well, typically when you have a larger tube, right, you have a stronger body. However, these are not the same alloy. The Turner one here, this is made out of 6061 aluminum, right? Very common, you know, aluminum alloy used. And the SPL is made out of 2024 aluminum. So we don't see that as common on you know, car parts, but it is pretty common on aircraft parts. And the reason why is 2024 is a stronger alloy than 6061. And so what that means is for the same equivalent strength, the SPL can be thinner in overall diameter. And you know, if I look at the diameter of the tube section here, this was a hair over 22 millimeters, so let's say 22.05. And on the Turner one here, this one was 25.8. So we have about like 1.9 millimeters extra wall thickness on the Turner versus the SPL. The rod end threads are exactly the same, which is why I can say that the wall thickness is, you know, so much more on this one. But for overall strength, you know, 1.9 millimeters is a significant amount. So, you know, it's still possible that this could be a stronger part than the SPL. But in case you're wondering, that's just kind of an interesting difference that I've seen. And then once again, you know, Turner sells this exact same SPL part, just with their, you know, blue color and their name on it as well. So what I'm going to do is I'm going to put this in the toe section. I'm actually going to move this to the forward lower arm section in the rear suspension because, you know, it uses the same arm. If you have an M3 or M4, this is a pretty simple job, right? You can see we have our bolt over here, right, which secures the toe arm to the wheel carrier, and inboard of that we have another bolt in here which secures the arm to the subframe. If you're semi-unlucky to have an M2, we have a bit of a clearance issue. So if we look at that inboard most bolt all the way in there, what you'll notice is it can't actually come out all the way because it's going to impact the body down here, and that's that little compartment where the battery is, which means we have to drop the subframe about 1.5 inches in order to get enough clearance so that we can actually get a tool in there and also pull the bolt out. Now let's send the car up. Now we can go ahead and take our wheels off, so grab your 17 millimeter. And make sure you're applying some pressure on the bottom of the wheel when you do your last bolt so it doesn't come off. You can go ahead and take the wheel off. We have to remove this panel underneath so that we can access the other side of this bracing here and remove that. So we're going to start with these two T30 just little plastic screws on either side of this Torx bolt here. At the front edge of that panel, where it mates up with this kind of fuzzy lower body panel, we have two more expanding plastic rivets to remove. On the bottom of the wheel well liner here, we have an expanding plastic rivet to remove, as well as an 8mm screw. So we can go ahead and slide this panel towards the rear of the car and out. Next, we're going to remove this lower brace piece. So we have to disconnect it from the other brace and disconnect it from the car over here. So we'll use a 6mm hex on these two smaller ones. And a T60 on this big one over here. In the middle here, we'll have to undo these 6mm hex bolts, which connect the center support brace to the braces going to the rear sides. And once these bolts are out, we can just slide the center piece out. Now we can work on the last two bolts and one nut holding this brace to the car, and these are all going to be 16mm. Next, we're going to remove the cables for the exhaust valves, and you can see there's a little tab at the top that you press down, and that'll let you pull the connector out. So press down on it, pull it out. Then we can place a jack underneath the rear exhaust so we can lower it controllably, and also put a jack stand there to catch it. To lower the exhaust, we'll have to access the mounts, and there's one on each side with a 13mm nut on it. And there's another mount in the front that we have to undo with a 13 as well. Next, we'll take a look at the e-brake line, and you can see the little hook that it rests in. Let's just go ahead and pop that out of the hook there. And then there are other assorted lines we need to check to make sure, they have enough like play or give, so that when we lower the subframe a little bit, we're not going to accidentally pull any wires. Here you can see the wire going to the differential, as well as two of the other wires going to the rear wheel carrier. Next, on the bottom, we're going to undo the 18mm nut in the rear and the bolt from the front in order to take out the damper. Now it's time to get our jack in place, and I'm going to put my jack on the differential. Even though this M differential has a bunch of fins, you can see I have a block of wood here, so it's going to spread the load out evenly along the fins. And I'm not placing the jack further back because you can see this is angled upwards versus this forward part is more flat. So it's pretty obvious where that corner is, where it flattens out. So I'm just going to go ahead and place my jack over here and get everything up and loaded so that I can lower the subframe. So now that the subframe and diff are loaded up so it's not going to lower as we undo the bolts, we're going to go ahead and start to undo the subframe bolts. And so you can see here in the rear we have one E18, and then as we pivot towards the front of the car, you can see we have another E18 right here. So there's only two bolts on each side that we need to undo. And you don't really need to undo the front bolts as much, since we're really looking to lower the rear. Okay, so I've loosened all my subframe bolts, and you can see the forward subframe bolt is in this cylinder here. And for the forward ones, what I've done is I've backed it out about a half to 3/4 of an inch, so the flange is kind of around here where my finger is. And for the rear subframe bolt, I've backed it out so the flange is equal to where this little lip is here at its highest point. It doesn't look flush in this picture right now because the subframe is lowered away from the body just a hair. So now I'm going to go ahead and lower the diff and the subframe till that bolt clears the battery compartment. One of the other things that I want to do is I want to take some measurements of my alignment setting with the current arm so that when I put the turner adjustable one in, I can set it as close to my current alignment as possible so the car doesn't drive totally wonky on the way to the alignment shop. So what I'm going to do is I'm going to take my tape measure, and on the inside what I'll do is I will place the tape measure right at the corner there where that little bend is. And then on the outside portion of the arm, I'm going to go ahead and measure what the distance is from that inner corner to this outer ridge of the eccentric channel is. So for me on this arm, that measurement is slightly more than 14 1/4, and I'll need to do the same on the other side as well. Now we're going to remove the old arm, so we'll start with our 18mm counterhold on the bolt on the bottom, and we'll use our 18mm socket on top, and we'll go ahead and just impact this off. Then we can go ahead and remove the bolt, nut, and the eccentric washer on top. Now we can move over to the subframe bolt, and we'll use our eTorx 14 on that. Then we can go ahead and remove that bolt and then pull the arm out. Now we're going to get the Turner arm ready for installation. If you look here, it comes with a number of spacers, and on the left is a shorter spacer, on the right is a taller one. The shorter spacer on the left is going to be used for the wheel carrier side, and the thicker spacers are going to be used in the rear for the subframe side. So I'm going to start with the thicker spacers on the subframe side. Go ahead and get that in there, and then put the bolt through. Now I can take the thinner spacers and go ahead and put that on the eyelet on the outside, and it doesn't really matter which side of this arm goes towards the subframe, which comes out. You know, it's pretty much the same either way, and the spacers really just dictate the side. And then you may have to articulate the ball joint a little bit. If you're having trouble moving it by hand, you can get more leverage by putting the bolt in there, right? So articulating it so it lines up with the knuckle. And as you can see, my arm is way too short to get to the knuckle now, so I'm going to go ahead and spin the arm so it's the length I need to get aligned with the bolt hole in the wheel carrier. And then once this is aligned, we can go ahead and get our bolt ready. You'll notice there's the eccentric lockouts, and you know, one side's got this rounded side which matches the indentation on the arm or the wheel carrier. So make sure that that's matching the right way on top, and then on the bottom we'll do the same, except we'll go ahead and put that on the bolt. Then we can slide the bolt up from the bottom through the top. Make sure both of the eccentric lockouts are in the indentations, and then we can go ahead and take that nut on top and secure it. To lock it down, we can take our 18mm counterhold on the bottom and 18mm torque wrench on the top, and we'll tighten this to 100 Newton-meters or 74 foot-pounds. Next, on the inside bolt, we'll take our E14 and once again torque that to 100 Newton-meters or 74 foot-pounds as well. And with all of our arms in place now, it's time to go ahead and jack the subframe back up. Now that the subframe is all the way up, I'm going to go ahead and take that E18 again and snug up the subframe bolts. And I'm going to do both the front ones first. Then I'll go ahead and do the rear one. Then we can take that same E18, put it on our torque wrench, and tighten these bolts to 108 Newton-meters or 80 foot-pounds. And once again, we'll do the front two first before the rear. Now that the subframe's all bolted up, we can go ahead and take our jack out and move it over to the exhaust and start putting that back up into place. Now let's go ahead and put our exhaust hanger back on the post up here. And we can also take our 13mm nut and get that started. Then we have the same in the front over here, taking our hanger and putting it on the post, and then starting that 13mm nut. Then we can finish tightening them with our torque wrench and go to 19 Newton-meters or 14 foot-pounds. Now that the exhaust is all bolted up, we can go ahead and remove our jack stand and jack.
Don't forget to re-secure your e-brake cable in the little hook there. Now let's go ahead and plug in the cable for the exhaust valve. Now we can go ahead and place the bolt that secures the damper from the bottom, and that bolt enters from the front. And then next what we'll do is we'll just start the nut on the back side, but we're not going to tighten this all the way yet. And then while we're here, we're going to jack up the wheel carrier some more to try and get it as close to the normal position as possible. So that is the position this wheel carrier is going to be when the car is fully on the ground. And the reason for that is so we can tighten the damper nut and bolt. The bottom of the damper has a bushing in it that should be tightened as close to the normal ride height as possible, because what happened is that bushing, it'll twist, right? But since it's not a monoball, it has a natural resting state. And if the suspension is fully unloaded and you clamp it down there, then when it's sitting here, there'll be some load or some twist imparted on that bushing, which it doesn't want to naturally experience. So we'll go ahead and take our 18mm, counterhold the front of the bolt and torque wrench on the rear on the nut, and set that to 100 Newton meters or 74 foot-pounds. Next we can let our jack out and let the wheel carrier rotor assembly go down. Okay, so we're going to start putting bracing back now. So I'm going to start with this side brace here that goes over this post. And then I'm going to go ahead and take the 16mm nut, get that started here so it doesn't fall on my face. I'm just going to get that done hand tight to start. And then further along the side of that brace, we'll go ahead and take our 16mm bolts and get these started in the holes too. Once again, just doing hand finger tight. We need to have a little bit of play in this brace so that we can get everything aligned later. On the very side here, let's go ahead and take the T60 bolt and this other brace piece and get that started. Once again, we're not going to tighten this absolutely all the way. We're just going to go finger tight, so that way we can rotate this piece out of the way as we play with the alignment of it. In the middle of the section of the car, let's go ahead and put this brace in, and we'll slide it in between the body and these other braces, which go to the kind of rear section. And then we'll take all of those 6mm hex bolts and get all this fastened together. Then we'll take our 6mm and torque wrench and tighten these out to 24 Newton meters or 17.7, you can just call it 18 foot-pounds. Now we can start fastening or torquing all of the fasteners on these braces. So we'll start with this nut here, and this is going to get tightened to 79 Newton meters or 58 foot-pounds. Then next are going to be the two 16mm bolts up here, and that's why we need to be able to swing this arm out of the way. And the torque spec for those is going to be 56 Newton meters plus 60 degrees if you're using new bolts, or if you're reusing bolts, just 56 Newton meters, which is 41 foot-pounds. Now we can go ahead and swing this brace back in place, put the 6mm hexes in there and tighten those to 24 Newton meters or 18 foot-pounds. And then we have the big boy T60 at the very edge, which gets torqued to 100 Newton meters or 74 foot-pounds. Now let's get our bottom cover into place. So right in the front kind of just slides on there. And we'll want to align the expanding rivet holes. And we'll go ahead and replace those two expanding rivets. On the rear side of that panel where the wheel well liner is, we'll go ahead and slide this behind, and then we'll put the expanding rivet in on the outer hole and 8mm inboard of that. And then lastly on this panel we have our two T30 plastic screws.
Now we can go ahead and put our wheels back on. Don't forget to apply a little bit of pressure on the bottom just so it's not going to tilt and come off. And then we'll go ahead and grab our 17mm with the bolts and put them in a star pattern, but we're not going to torque them to final torque just yet. Alright, with the wheel on, you can go ahead and lower the car.
And then lastly, don't forget to torque your wheel bolts to 140 Newton meters or 104 foot-pounds in a star pattern.